When I first got into web development, I didn't really have a good understanding of like how much traffic can a web server actually handle. So that's why I want to try to like show you today. I have a single DigitalOcean droplet. It's one of the smallest VMs they have. It's 512 megabytes. I think it's like $4 a month or something. And I wanted to see like how much traffic can the smallest machine possible that's like $4 a month handle with a Next.js application. And this isn't going to be a thorough test. I just have a really basic Next app with one page. This page has a couple of images on it, so it hits the image endpoint a couple of times, which behind the scenes is going to scale stuff down. This is not behind a CDN, so there is no like caching going on from what I understand. The question I want to figure out is like how many times a second can someone come here and just like refresh this page before my server starts to slow down. At some point, you're going to either have to start horizontally scaling, which means you add a bunch of different machines behind the load balancer so you can handle more traffic, or you have to vertically scale your machine. And with Node, it's a little bit more difficult because Node is single threaded. So you'd have to use something like PM2 to basically spin up your Node application with multiple threads under the hood with like multiple workers. Okay, so I got a DigitalOcean droplet. Like I said, it's the smallest one possible. And maybe I'll scale it up later in this video. Let's just kind of see like how much a higher box can handle. So I took the IP, I'm over here, I am SSH'd into that box. And if I do a PM2 list, you'll see I have a process running, right? So this is the next application. It's here in this directory. And there's nothing special about this. It's the same thing I just showed you. And we wanted to determine how many times can a person just sit here and keep like refreshing the browser on your site before it starts to fall apart. Okay, so I'm going to show you another tool that is I think used pretty often in the industry. It's called Apache JMeter. And this is a really powerful tool for basically doing load tests and verifying stuff is performant when you need to like make sure everything's good. It's written in Java. You basically download it and you run the JMeter that's in the bin directory. And what you can do is you can set up a test plan. And inside the test plan, you can set up a thread group and say how many users do you want to basically spin up. And what those users are going to do is I told it I need this to just loop forever. Just keep on doing whatever the test plan is over and over and over again with one user. The test plan is basically saying just do a single HTTP request to this box. Notice here I have HTTP, the IP, port 3000. So that is the same thing that's up here. So that's going to hit the DigitalOcean box. It's going to hit the index of Next.js, and that's going to run whatever Next is doing to host or server-side render that file. I do believe this is not server-side rendered. I think this is just a static file. But as you can see, a single load to this application does 13 different requests. We have all these different JavaScript files that come in, and we got some image stuff going on here too. And I will say that if the same user is actually hitting your machine over and over again, these assets will be cached in the browser. So in order to test this, I'm basically simulating if a new user, brand new user, loads up their Chrome browser, goes to your app, how many times a second can that happen before your server starts to slow down or starts throwing errors? Okay, and then I'm saying do a GET request on this path. Now, when you run this, you have the ability to get different graphs and results and stuff like this. We're going to try to dive through these results and just kind of see what happens. So let's just start. I'm going to do a single user and just infinitely loop forever. So if I run this, in the top right corner, you can see that it's at one thread going right now. And this is the timer. And after about 10 seconds, I'm just going to go ahead and stop. And let's just go ahead and look at some results. So let's go to the aggregate report down here. You can see that the average response time was 175 milliseconds. And what this means is that's how long it took the test to basically load up the HTML file and then subsequently download every single asset that was on there. So if you go here to advanced, HTTP request advanced, you see I have this checked, retrieve all embedded resources. So that's kind of simulating the browser where like when the HTML page loads, it's then going to go and load every other script or chunk that's needed. And you can kind of view this happening. If I click on any of these HTTP requests, you can see that it's loading different things. So like this is doing the static chunk here, and then this one is doing another static chunk. One of these points will hit the images. Some more static stuff here. Here's a next image request. So you see JMeter is kind of simulating the browser without actually having the browser open. And it's doing a request and downloading all the assets just like a normal user would. And the benefit of this is you can actually see how much traffic can your server end up handling. So this is the baseline. One user refreshing, and when all the assets finish downloading, it just refreshes again. Seeing a throughput of like 5.7 requests a second. And the average is 175 milliseconds for these requests. So what you can do is you can start bumping this up. Let's say 5 users are just constantly just sitting there refreshing the page. So how many requests per second will happen? Let's go ahead and clear this. I'll clear this as well. And I will click run for about 10 seconds. And you'll notice here on the graph, like the throughput's kind of leveling out. So it's kind of hitting a point where it's like it can't get any more faster than what this throughput is. And the throughput down here is saying, so the throughput is about 880 something, about 15 requests per second. Now I will point out that as the requests are going up, so notice that this curve is logarithmic. So if you go over here, this is what a logarithmic graph looks like. And I believe that at a certain point, you're getting like diminishing returns, right? So after like the server's like warmed up, everything's kind of leveling out. And this is kind of like the average throughput that you're going to get with 5 users. But notice that one thing you need to point out is that the request time actually is a little bit higher. So if I go back to the report here, the average request time is now 333. So although yes, the server could handle those requests, the server dropped down and actually took twice as long to handle that many requests. Now, how many requests was that over a 44-second period or whatever? That was 670 requests. You can see here there's a throughput over here of about 15 a second. And then it's kind of up to you to determine, because I can bump this up like super high. I can make this like 50, right? And I'll ramp this up slowly so it doesn't just like overload my server like real quick. I'll say like 10-second ramp up. But it's up to you to kind of determine like at what point is the sweet spot of my application. Actually, I'll keep it at 15. At what point, so like I was saying, like at what point is the point where like, okay, maybe I need to scale this up. This server is becoming too slow. I can't handle that many requests. Let's go ahead and do it again. I'm going to go ahead and just, why does this keep getting disabled? Let's just go ahead and run it again for a little bit. So now if you see here, the average is hovering around 450, 460. And as it's running this test, I can go to my app and I can refresh and it works. Just notice that it is a little bit slower, right? Everything is about taking twice as long just to load these assets, but it works. I'm literally hitting the server with a bunch of requests behind the scenes. And if I was a normal user who came in, I wouldn't even kind of notice that there's a slowdown. So not too bad, about 461 to download the entire page. We get 32 requests per second as a throughput. Look at the graph over here. And again, it's kind of leveling out over here at 1,830 requests per minute. And here's the average request time, 146. So again, you can kind of just keep bumping this up. At some point, you're going to hit a point where it's like your server is just, the response time to your server is just going to be too high. And like, that's the point where you just need to kind of start scaling in different ways. So let's try with 25 users. So now the average response time is about 800, 900, 700, a little slow. Let's go ahead and refresh the page and notice that it does take a little bit longer to process this request. Okay. Like it's still pretty speedy. I mean, we're talking like milliseconds here, 200 milliseconds. Okay, so I don't know if we hit a threshold there. The average dropped down to 600 and something. The throughput is 36. And we get this graph. I'm not really too sure how to read this graph. I mean, I guess it tells you like how your service ends up handling this traffic more over time. And like it averages out to like 600, 700 there. But let's just go ahead and I'm going to do a big one. Let's just go ahead and go to 50, clear this out. I'm going to click run. And now I'm basically like DDoSing my own server, right? So the average response time is hitting about, 1.5 seconds. And if as a user, if I go here and try to like refresh this page, you'll notice that stuff is just super slow, right? Like look how long it took to load these assets. We're talking like 1.5 seconds for the DOM, 1 second for the actual HTML, and then the JavaScript was like another second, half a second for this. Images is 1.6 seconds. So you've kind of reached a point where it's like, okay, this is kind of where I need to like have my upper limit in terms of like scaling. I probably can't handle that many requests per second. And notice the throughput is still 35. So like, I think that's kind of like what you're hitting. 35 requests a second might be the max of a single DigitalOcean machine. So that's kind of like what you can do to like, understand how many requests a box can handle. And notice that that's quite a lot. To have, that many requests a second happening on your server, a single DigitalOcean box with 512 megabytes of memory, that's quite a lot. And if you're starting a new company or you have a small side project, this is going to handle the traffic. You're not going to have that big of an issue. It won't handle a DDoS, let's be honest. If you need to be able to handle DDoSes, which are probably going to be kind of rare, like people keep talking about bot attacks, but I don't know how often a bot attack actually happens on like little side projects. But you're going to have to want to do like load balancer, multiple machines. You probably just want to use like some Amazon auto scaling type of thing. And then you probably want like Cloudflare in front of it to really prevent it from getting hammered. So let's just go ahead and do like a premium Intel here. I'm going to scale this thing up for a little bit. This has 2 cores with 2 gigabytes of memory. It charges $21 a month. And I'm going to run that same test that we were kind of running earlier and see, does it perform better? Okay, it says my droplet has been resized. So basically to resize your droplet in DigitalOcean, you can't do it live. You have to turn off your service, resize, turn it back on. So again, that's another thing you gotta have to consider. Is having some downtime acceptable in your application? And in most apps, I would say, yeah, it's fine. Just at midnight, turn off your box, scale it up, turn it back on, and you should be good to go. But in some cases, depending on your uptime requirements, that would be a big no-go. Some applications require you to have like 9 nines uptime, which means you can only be down for like a certain amount of minutes a year. And this wouldn't work, right? So depending on your project requirements, which for a startup, I mean, it's fine. Like, who cares if your app goes down at night? But if you're a multi-global application that needs to be up as much as possible, this will not be something you can do. So let's just go ahead and SSH back into that box. Okay, and now we got, let's see if my PM2 is running. So now what we can do is we can run this, but I'm also going to run it with, so we're going to run PM2 in cluster mode. That basically is going to allow more requests to hit your service. You basically give it an IMAX here. So let's just go ahead and say PM start IMAX. And I think that's all you got to do. Let's see. So this should hopefully utilize how many cores is on your machine and spin up your service in cluster mode. So now I have basically 2 Next apps set up, and they're kind of load balanced between PM2. And this is all on the same machine. So we are vertically scaling at this point. We're not even horizontally scaling, we're vertically scaling, and we're going to try to see how much more traffic this thing can handle. Let's go ahead and refresh the page. Notice that we get a request now, and it's pretty performant. We get like 50 milliseconds. Let's go back to our load test. And before, we're getting 140 or 1400 milliseconds for our average response time, and then 35 a second throughput. Let's just go ahead and clear this out and run it again and see, can the server handle much more traffic? And it can. It's just not that much of a big increase. I mean, all we did was add another core to this. So it's able to process more requests. Notice that the average has dropped down to almost 1,000 now. It was about 1,400 before. Now it's about 1,100. And this will continue to drop down until it stabilizes. And the throughput went up from like 35 to 46. So yes, this thing can handle more traffic. And again, if I were to just refresh this page, let's view how long some of this stuff takes. And this, we're not seeing a second on any of these things, which was before we were seeing like 1.5 seconds for images and stuff. Just with basically turning off the machine, scaling it up and turning it back on, we were able to handle, I want to say twice as much traffic, but a decent amount more traffic. And at some point, if you need, you can scale this up again. Now, obviously with Node, they kind of expect you to horizontally scale and not vertically scale, because you could actually have 4 or 6 of these 1-core boxes spun up behind a load balancer, and that's going to handle a lot more traffic than doing something like this. Go ahead and stop this before I get a huge bandwidth bill for just DDoSing my own service. But finally, we got the throughput of 51 a second and 961 milliseconds for the average. So this is much better than it was before. Scaling up the box did improve a lot of the traffic. And the only reason I'm getting errors here is because I just stopped this and that kind of kills all the connections. Like, let me show you that there are no actual errors here. If I just run this and don't stop anything, I won't get any errors. But the moment you actually stop this thing, your error count like drops up because it kills a bunch of like living connections. So let's go ahead and click stop and notice that the errors go up. So we weren't getting any errors before. And that was the kind of the throughput we're seeing. Those are the things you have to worry about if you do decide to run your own machine on a VM and like you want to manage all your infrastructure yourself. You have to keep in mind and like try to figure out these baselines of like, first of all, how much traffic is my app getting? Right? One way you can do that is you can go to like Google Analytics and just look. And this is for my own personal site. Like this is my icon generator site, which I think you guys have seen. Which, by the way, I have a course for this if you guys are interested in seeing out how to build out this SaaS product that connects with Stripe, Nextauth, T3 Stack, Prisma, Supabase, where you can basically go here and you can generate icons. The course link will be in the description of the video. But what I'm trying to get at is this is a SaaS product that is actually getting some users. Like people are coming in and generating icons and paying for this. I'm getting like 20, 30 bucks a month from people buying icons. But my point is, how many people are actually hitting this site a day? I have about 1,254. This is how many requests a second I'm getting, which even for the smallest DigitalOcean box, it's like nothing, right? Let's just do requests per minute. I'm getting 0.87 requests a minute, which is nothing. So you have to kind of take a holistic view of like, okay, what is my traffic? How much traffic do I expect to get? How much traffic do I need to handle? How much traffic can my DigitalOcean droplet handle or whatever service you're using handle? And that's how you can kind of gauge like how many servers you might need. Again, always follow through with a little bit of load testing to make sure that you understand what's going on. But I just figured I'd make a quick video and share that with you all. I know this video isn't quick anymore, but hope you guys learned something new about just kind of like doing more metrics into your running services. And if you guys like this, give me a thumbs up, comment, subscribe, like. And like always, I have a Discord channel you're welcome to join if you just want to find a place to ask questions or get some feedback on your coding. All right, have a good day and happy coding.